So normally when we think of three dimensions, we like to think of flat land as being this two-dimensional plane of which many little creatures live on. They might have like an eye on one side of them that allows them to sort of understand their surroundings. In nature, you see like flat bacteria with flagella. Those are the tails, and what's the name for it? There's little hairs on the. I forget the name, but they touch each other like that. So, like when you normally think of a two-dimensional representation, you think of length, width, and of course height, right? And this gives an object its dimensions, right? And we think about how objects have these bounding boxes around them possessed by the length, width, and height, because we're assuming that our sense of dimensionality is orthogonal. That is to say, it's at right angles to each other, and that's the case for the majority of our interpretation of mathematics and in linear algebra. It's assumed that they're orthogonal to each other, but orthogonal does not, I think, it does not necessarily mean right angles. It means perpendicular to oneself. So if one takes the right-hand rule, right, we think about how this is one vector, this is another vector, and when we where's my square? So if we think about there being multiple vectors, right? If this vector is going in this direction and this vector is going in this direction, then the resultant vector is upwards, right, in a new dimension. And the same thing if it's, well, yeah, I forget exactly what the right-hand rule is, but you get my point. Well, my point is that if we think about the projection of 3 space onto 2 space, you get essentially what's the isometric grid. So if you, I could draw the cube in here, but so if you connect these lines, you can see the top of the cube, the one face of the cube and another face of the cube there. And depending on how you color them, right, they tell you what surface, what orientation you're on. You can assume that there's the finished cube on the other side of it with the other colors on it, and the faces of the cube, the color that it's on, determines what direction you're facing. It's kind of like a way to map colors to normals. But you can see that each of these little segments are 60 degrees, right? And now, if you think about that cube having the different directions, right, then this one in the isometric grid, this one represents the z-axis, this one represents the y-axis, and this represents the x-axis. Now, if you think of these as being spheres, right, and you complete one sphere here, a semicircle, and you connect this to its peak, now you got a 4-dimensional axis, right, representing a direction that could really only to the beings of this 3-dimensional plane be seen as inwards, or be almost like a sense of scale. Because if you think about this, if you take this axis and make it like this, it's almost like a radius, right? But you're going in a different direction. This would almost appear to scale because you're kind of looking at a sphere. You know, you're talking about the Aesir character from Gladland, right? And he is on this, and you can see how that would work, right? But this can be generalized. So if you take the tetrahedron, right, and that's what's known as a simplex if you connect it in 3 dimensions, right? And you have the tetrahedron, a shape being built out of these generalized equilateral triangles in n dimensions. Now you have a conception of n spheres. Elsewhere, I have a impossible geometry construction from the Seed of Life, and you can use that. And if you assume these go to this value, if you let your compass width tend to dx, right, then you can have like a representation of n space, an isometric n space, where anything can be represented, any number of dimensions can be represented in 2 dimensions, assuming that you're looking at a projection of it, right? The shadow, like on Plato's cave. But yeah, it's an interesting just understanding of different ways of representing space, and I thought that this was the Seed of Life is a pretty fascinating construction with a lot of study potential.